Hi guys, welcome to the Unit 4 review. Just as a reminder, you will have to take a 2-question assignment in Schoology and score a 100 in order to unlock the Unit 4 test retake in Schoology. But both of those questions are going to come straight from this video, so make sure you watch and take notes so that you can complete the retake. So here we go. Solve for x and show all of your work. So when I solve equations, I like to draw the line down the equal sign, and I like to box off my letter, find my letter. My goal is to get the letter by itself, so I need to get rid of everything else on the same side. In this case, I need to get rid of negative 41, and the opposite of subtracting 41 is to add 41. But whatever I do to one side, I have to also do to the other. Those will cancel. I'm going to bring that x squared straight down. And then 128 plus 41 is 169. Now the x still isn't by itself. If you find your x, we still have an exponent of 2 or a power of 2. I'm squaring it and I need to get rid of it. So the opposite of squaring is square rooting. I'm going to square root that side, and whatever you do to one side, you have to do to the other side. The squares and square roots cancel, leaving me with just x. And the square root of 169 is 13, which is your answer. A little bit later on in other math classes, you'll talk about positive and negative 13, but for right now, it's just going to be positive 13. Mr. Allen leaned the ladder against a wall. When placed, the ladder reaches the top of the wall. If the ladder is 15 feet long, and Mr. Allen places the ladder 9 feet from the wall, how tall is the wall? So I'm going to give that the letter X. All right, well, this makes a right triangle. It even puts a little right symbol down there in the corner. So we know that we can use the Pythagorean Theorem. A squared plus B squared equals C squared. Now, it's really important anytime you use the Pythagorean Theorem that the hypotenuse, or the side across from the 90-degree angle, that's always the longest side, and it's always going to equal the letter C when you plug it into the formula. So when we plug these in, I'm going to plug them in least to greatest. So 9 squared plus x squared equals 15 squared. And then I'm going to square them. So 9 squared is 81. 15 squared is 225. And now I have an equation. I am solving for the letter x. So I have an 81 that I need to get rid of. Right now it's a positive 81, so the opposite is to subtract 81 from each side. That would cancel. I'm going to bring this x squared straight down. 225 minus 81 is 144. But that's still not my answer because I still don't have x all the way by itself. There's a power of 2. I'm squaring it. The opposite of squaring is square rooting. So I need to square root both sides. The squares and the square roots cancel, and the length of the ladder is, the length of the wall, the height of the wall is 12. Which numbers below are rational? Okay, so remember, irrational numbers are numbers that are decimals that do not repeat and they do not end. So they can't be written as fractions. So that's irrational. So anything that's a really long, ugly decimal that can't end or repeat, we know it's going to be irrational. So if we look at this, -5, that is rational. Yay. This one's a really long decimal, but notice it goes 4, 3, 4, 3, 4, 3, 4, 3, 4, 3. That one repeats. So you can actually write that as a fraction. So that one's also rational. This one's a really long, yucky decimal, and it doesn't repeat. So I know that that one is irrational. Oops. For 2/5, 2/5 is written as a fraction, so that is rational. And if you wanted to double check, you could do it in your calculator. 2 divided by 5 is 0.4, 0.4, and so I know that that's rational. For the square root of 3, if you do that in a calculator, it gives you, let's see, 1.7320508 keeps on going. So that one does not repeat and it does not end, so it is irrational. I'm going to type this next one in. The square root of 25 And I'm just typing it in a calculator, y'all. Square root of 25 plus 3, that equals 8. And 8 is a nice, pretty whole number, so that's going to be rational. And then let's see, the square root of 2 plus the square root of 9 gives me, 4.414213562, yuck, 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 yuck. So it doesn't end and it doesn't repeat, so that one is irrational. So what I did for all of these is I just typed them all on the calculator, turned them into decimals to see if they were rational or irrational. All right, what is the square root of 144 over 49? So for the square root of 144 over 49, you can split that apart into two separate square roots, or you can type in your calculator. I'll show you both ways. So you could go to your calculator and type in square root of 144 over 49, and it's going to give you a decimal, but we're probably going to want the answer in a fraction, so you can hit that convert to fraction button, and it'll tell you 12 over 7. 12 over 7 makes perfect sense, because if we would have done it the other way, where we split it into two separate square roots, the square root of 144 equals 12, and the square root of 49 equals 7. So you can either split it or do it in the calculator. To estimate the square root of 75, what two square roots should you use? Now, if you remember all of your perfect squares, you might already just immediately know that that's between 8 and 9. But if you don't automatically know, you're going to go to your calculator and you're going to type in the square root of 75. So if I type in the square root of 75, it's going to tell me 8.66602, whatever. So I know that the square root of 75 is between the numbers 8 and 9, which means it's between the squares, 8 squared and 9 squared. So if I want to know which square roots it's between those two. So I could use the square root of 64 and the square root of 81, because 75 is in between those numbers to help me estimate. A triangle has sides of 27 inches, 36 inches, and 45 inches. Is this a right triangle? Well, in order for it to be a right triangle, the Pythagorean theorem has to work. So I'm going to plug them in from least to greatest into the Pythagorean theorem, and I'm just going to see if it works. Excuse me. So I'm going to calculate this side in my calculator. So 27 squared plus 36 squared, that equals 2025. And then I'm going to calculate the other side of my calculator, which was 45 squared, and I'm going to see if they're equal. Since they're both equal, then yes, I know this is a right triangle because the Pythagorean theorem holds true. If you had calculated it and those two sides were not equal, then the answer would be no, it's not a right triangle. But since they are equal, then yes, it is a right triangle because the Pythagorean theorem works. Which of these is a Pythagorean triple? We're going to do the exact same thing. We're going to plug them into the Pythagorean theorem, and we're going to see if they're equal. So I put each of these into my calculator, and on this first problem, I got 3,600 equals 3,844. That is not a true statement. So that does not make a right triangle. So this one is not a Pythagorean triple. Over here, though, I got 2,704 equals 2,704. That is a true statement, so this one is a Pythagorean triple. So this one doesn't work because they're not equal, and this one does work because they are equal when you plug them into the Pythagorean theorem. For this one, label the four quadrants on this graph. So over here, where both x and y are positive, that's quadrant 1. And then we go counterclockwise. So next we have 2, 3, and 4. What is the coordinate point of the red dot on the graph? So right here. So this is a positive 1 for an x value, and whenever we write ordered pairs or coordinate points, they're always x, comma, y. So my x value is at 1, and my y value, which is this one, is at -1, -2, -3. So my x is 1, my y is -3. Which of the following shows an example of two irrational numbers being multiplied to get a rational number? Okay, well, to start off with, 3 and 9, those aren't irrational, those are rational. So we can go ahead and mark that one out because we want to be multiplying two irrational numbers. 0 is not irrational, so I can go ahead and mark out that one. The rest of these, though, square root of 2, square root of 5, and square root of 8, those are all irrational numbers. So we're just going to multiply those together. So this one would give you the square root of 10, and this one would give you the square root of 16. Well, the square root of 16 equals 4, which is a nice rational number, which is what we wanted. The square root of 10 is some ugly decimal. Let's see, square root of 10, it's like 3.1622, blah, 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 blah. So that does not give me a rational number. So my answer is D. Oops. Which number is a perfect square? So a perfect square is just when you take a number and you square it. So like 1 squared, or 2 squared, or 3 squared, 4 squared. I'm going to keep on writing these. 5 squared, 6 squared, 7 squared, 8 squared. Anytime you anytime you square a number, what it equals is a perfect square. So this whole column right here represents perfect squares because we got them by squaring a number. A whole number, I should say, or an integer. Oops. So you can keep going. You can make your list as long as you want, but all of these are perfect squares. So if I'm looking at my list of perfect squares, 5 is not a perfect square because if you take the square root of 5, it's going to give you some irrational decimal. 12 is not a perfect square because it would equal some irrational decimal. 15 is not a perfect square, but the square root of 49 equals 7, which is a nice whole number, which means it is a perfect square. All right, guys, make sure you go into Schoolology, take your 2-question quiz to make a 100 on it. Both of those questions come straight from this video, and then you will be ready to retake your Unit 4 test. Good luck, y'all.